436 is scale drawing. Now, a scale drawing isn't a drawing of a scale. A scale drawing is a drawing of an actual object or actual room or something that is either too big or too small and needs to be either shrunken down or enlarged in order to try to find the missing measurements. Floor plan on the right is a model of an actual room. The model and the actual room are similar figures. Similar means same shape, different size. The lengths of the corresponding sides of similar polygons are proportional. Corresponding parts of models and similar real objects have the same ratio. This ratio is called a scale. You can use a scale on the drawing at the right to find the length and width of the actual room. Okay, so what a scale is, and what they show us is that the scale is 1 inch to 4 feet. What does this mean? I can explain what that means to us. Does anyone know what that means? And then we'll get into when other situations we see scales. Liam. What does this mean? 1 inch to 4 feet. 1 inch in the drawing is equal to 4 feet in real life, or the actual. Okay? So it's shrunken down. Think of, where else do you see scales like this? On a map. And maps are always shrunken down, because if they weren't, the map itself would be the same size of the area that it's mapping. Think if you had a map of the city of Milwaukee and it wasn't shrunken down. That map would be the size of the city of Milwaukee. So they shrink everything down, but everything is proportional. Okay? So if it's actually, if it's actually 30 miles from one side of the city to the next, they're going to shrink it down so that when you measure it on the map, it's still going to measure out to be 30 miles from one end of the city to the next. Okay? So everything is done in a way in which they are proportional. Remember when we worked with the rectangles? And we talked about different kinds of rectangles, Larissa, remember that? You especially? And we said, okay, we can have a rectangle that measures the long side of 6 and the short side of 3, which means they would have a what-to-what ratio between long and short sides. A 6-to-3 ratio simplifies to a what? A 2-to-1 ratio. Now, in order for this rectangle to be similar, it would need to follow that same ratio. So if I had a long side of 4 and a short side of 2, does that particular rectangle follow the same proportion? Yeah, it does, because it's also 2-to-1. What we came across, Larissa, was some rectangles that look like this, where the proportion was maybe 5 on the long side and 4 to the short. Now, when I put that in and tested for the 2-to-1 ratio, does it work out? 5-to-4 is not 2-to-1. So therefore, everything has to work out perfectly in order for it to be drawn to what they call scale. The good thing is you're going to get that information for the work that you're going to do. You're not going to have to come up with the scale. Okay, you're going to be given the scale, and then you're going to have to find out you know, is what is the actual length or what is the drawing, okay? So let's start a new page and let's use this. Now, I don't know about you, but I think it's easier instead of writing this particular ratio in this form using the colon, it might be easier to use what form? 1 inch is equal to 4 feet. Okay? So let's use that. And let's say that on the drawing, okay, the length is 4 inches and the width is 8 inches. Okay? That's the information that's been given. So if they give us that information, I can find the actual length and the actual width. So let's set up a proportion for the length and set up one for the width. And I'll use that same scale for both. Okay. So this is all set up in your notes. You're all set to go, right? Yes? Or should I wait a second? All right, so to find the actual length, I'm going to set up our first ratio, which is our scale, 1 inch to 4 feet. Now for the length on the drawing, what measurement is given? Are we given the inch measurement or the feet measurement? Inch. So where am I going to put it? At the top or at the bottom? Why top? Because that's where I put my inches on my first ratio. So I'll put it on top for this one. So now what's being done is exactly the same thing that you did for today. First thing we look for is a relationship. So from 1 to 4 times 4, 4 times 4, 16 feet. How are we going to set up the width? The width in the drawing is 8 inches. Where am I going to put the 8? On the top. Therefore, from 1 to 8, and then from 4 to 8. Okay. So in the drawing, I've got a 4 by 8, but in actuality, the size of the room is what? 16 feet by 32 feet. And that's how we would find the actual. The dimensions of the room, if that's the scale. Okay. Let's take a look at guided practice, page 437. And let's look at number 1. Use the scales to find the actual measures of each object. Okay. Now the scale says 1 inch to 5 feet for a house drawing that is 6.5 inches by 5 inches. So are we talking about if they give us 6.5 inches by 5 inches, are those drawing measurements or actual measurements of a house? Drawing. No one lives in a 6.5 inch by 5 inch house. Okay? So let's set up our initial ratio. What's our initial ratio? What do they give us? What's the ratio they give us to start off the problem? 1 inch to 5 feet. Okay? So First one we have is 6.5. Okay. And then let's find the other one over here. And this one is 5 inches. Okay. So what are we going to do? How are we going to find these measurements? Does it matter which one well, let's take them in order. Probably makes things easier. Is there a relationship between 1 and 6.5? How would I get from 6.5 from 1? Times 6.5. That's the nice thing about using 1. Okay. So 6.5, could I use a decimal? 6 point what? Okay, so 6.5 times 5, 25. 32, how many decimal places? So 32.5 feet. How about over here, to get from 1 to 5? So 5 times 5. Okay. So now, if in the drawing it was 6.5 inches by 5 inches, the actual is going to be what? 32.5 feet by 25 feet. Okay. Real quick, why don't you just do number 5 on page 438. Do number 5 on 438. Just do number 5 on 438. Here's my scale. 1 inch is equal to 2 feet. And my measurements are 7.5 inches by 8 inches. Since I put inches on top, I can go 7.5 or 7.5. And over here, let's set up the 8ths. Okay? So the relationship between 1 to 7.5 is going to be what? So 7.5 times 2 is going to give me what? 15. How about over here? What's the relationship here? To get from 1 to 8 is times 8. So 2 times 8. So if in the drawing it's 7.5 inches by 8 inches, in actuality, it's 15 feet by 16 feet. All right, we got it. Okay. I want to show you something else that they're going to throw at you every once in a while. Like, let's go back to number 2. And the scale is 1/2 inch is equal to 1 foot. And they say that it's 3 inches by 2.5 inches. Okay. Now here's the thing. What's different about the scale than what we've seen in the past? What's usually been our top number? Whole number 1. But this isn't the whole number 1, it's half. Can I still get to where I'm going using half? I can. Can I change the scale? Here's the scale that I have right now. 1 inch to 1 foot. Could I change the scale to make a 1 on top like I'm used to? We can try. Is there a relationship between 1/2 and 1? Times what? 2. 2 halves equal 1. So if I multiply the top times 2, the bottom times 2 is... So I could use this scale because it means the same thing as this one. So which one would I want to use here? Can we use the 1 to 2? Can I use that one? to get from 1 to 3 times 3, 2 times 3. No, you won't get different answers. What if we stuck with the half? How many halves are in 3 wholes? 6. So if I multiply the original by 6, do I get 6? Right. I told you these scales are the same. We didn't change anything. The scale still means the scale. All we did was modify what we're working with to make it easier for ourselves. Yes. You don't have to change it. I'm showing you a shortcut. Is there a relationship between half and 2 1/2? How many halves are in 2 1/2? How many halves are in 2? 4 plus another one is 5. So 1 times 5? 5. What if I use this? What if I used our modified scale? To get from 1 to 2 1/2 would be times 2 1/2. What's 2 times 2 1/2? Is it still 5? Still works. So 6 feet by 5 feet. And the nice thing is that number 8 on the back side is just like that. So try number 8 on the back side. Try number 8 on that in the book. Okay, number 8, our original scale is 1/2 to 1. If I wanted to modify it, could I modify the scale? Can I put a 1 on top? If I did, 1/2 times what gives me 1 whole? 2. So 2 times 1. So in this case, again, I can use either one of these scales. They're the same thing. So number 8 is 3 inches by 1 1/2 inches. Okay. So which scale would you rather use for the 3, the whole number? The 1? All right, so times 3 times 3, 6 feet. How about for the 1.5, 1 1/2? Maybe use the half. How many halves in 1 1/2? 3. So 1 times 3, 3 feet. So our measurements, 6 feet by 3 feet. So yes, written down here for you are the plans for number 4, for number 6, adoption of a different scale for 7 through 9. You can use the 1/2 inch over 4, but you could also use 1 inch over 8. They mean the same thing. There's the setup for 9. And if you multiply 5.75 times 8 correctly, you'll get your correct answer for number 9. But the hard stuff has been mapped out for you.